That just as soon as I start recording, she's off. She's off. Welcome to the Ellipse, everybody. What we're going to be working on, it's the ellipse. It's just a complicated version of the circle. So we're going to work on that big box right in the middle of your conics summary paper. Here's our definition for an ellipse. It is the set of all points in a plane where the sum of whose distances from two fixed points, the foci, are constant. So foci being the plural of focus. So it has two foci as opposed to one focus and a parabola. A parabola was a point and a line. Now we're going to go point and point. And instead of the distance being the same, the sum is going to stay the same. So we're going to be connecting, you're adding a couple of things together. It's not super important. You should have this cool line right down the middle of it. It's got the focus, the foci, it's got the center, and it also has vertices. So we do have a vertex for this thing. And there's two of them. And all these points form a nice big line, and that is the major axis. There's a minor axis that goes up and down. Through the center, but all the major points of this thing form the major axis. It could also go major axis this way, and then there's a minor axis that way. Depends upon which of the two ellipses you have. So let's try to graph one of these things. This one's already in standard form for us. Now, it is difficult when you're doing an ellipse to determine which one are we supposed to do. Like if you look at these two things, I can't really tell the difference. Like sure, X comes first and Y comes second, Y comes first, X comes second, but how do I know which one it's supposed to be? You can rearrange the order. This is your key right here, and I actually wrote it twice to help remind you. The A value has to be bigger than the B value. So whichever one has a bigger denominator, that one's first, and that one's telling us A. The one that's smaller, that one is B, and it should come second. So we have the big number under the X, so that is telling us that we are doing a horizontal major axis, and we're going to do all this stuff for this part. So on this thing, let's identify our variables. This is A, but it's A squared. So from this, we can tell that A equals 3. This one is B, but it's telling us B squared, but it's still the same thing as B is 1. H is always with X, so H is going to be the opposite of positive 1, negative 1. And then K is always with Y, and that is going to be 3. And that should be all of our variables. So based on this, we have a horizontal major axis. I'm going to write that down before I forget. We're going to get some information about our major axis. Where is that? Length of our major axis is 2 times A, and 2 times B is going to get us our minor axis. So major axis is 2 times A, which in this case is 6, and then our minor axis, minor, is 2 times our B value, which is 1. Now, there's one other thing that we need. We need a C, and C is actually right here. Now note, this is not a typo. This is correct. The C value looks almost identical to the Pythagorean theorem, but it's got a subtraction instead of an addition. So I didn't mess up. That is correct. It is A squared minus B squared. If you look lower for next time with the hyperbola, I can't quite scroll to it, but whatever. With the hyperbola, it actually does have a proper Pythagorean theorem, but the ellipse uses a minus. So I got to figure out what this C value is. I'm going to need that for some stuff later. So it's C squared equals A squared minus B squared. So c squared equals our a squared, which happens to be right there, and there's our b squared. So 9 minus 1. So c squared equals 8. So c is the square root of 8. Now, if you want to, you could simplify that if you want. It's 2 square roots of 2, or you could turn it into a decimal, whatever you want. Or you could just leave it as square root of 8. Most of the time, we're going to make these things decimals anyway, so it doesn't matter too much. All right, let's move on. We need our center for this thing. We're going to go back over to here. So our center is always at HK. So our H value is -1 and our K value is 3. Our vertices are at H plus or minus A comma K, because we get 2 vertices, one on either end of our major axis. Sorry, I'm choking on something. So our H value is -1 plus or minus our A value, which is 3 comma K. So if we converted those into numbers, -1 plus 3, that is 2 comma, oh, I forgot, what's my K value? It's 3. Did I do that backwards? Oh, A is 3 and K is 3, so they're both 3. We just had multiple 3s and it threw me off. So -1 plus 3, and then 2, 3. And then -1 minus 3 is -4, 3. So there are our 2 vertices. Our foci is at H plus or minus C comma K. So that is -1 plus or minus our C value, maybe that's just square root of 8, comma K, which is 3. Then you would just type that into your calculator, -1 plus the square root of 8. I got my answer key up there, so I'm just going to quick write it down. Oh, come on. Oh, everything's frozen. All right. -1 plus the square root of 8 is 1.828, comma 3. And then -1 minus the square root of 8 is -3.828, comma 3. Yep. So now we just got to graph all this stuff. I'll start with my center. My center is at -1, 3. So boop, there's our center. Our vertices are at 2, 3. So we got a vertex right here and a -4, 3. So there we are. Our foci are just in a little bit from those two. That's going to happen pretty often. I know they're kind of like decimally things, but again, I don't really need this to be exact. Now, all those points are on a nice straight line and they're 6 apart. So my major axis is looking good. That line that goes through all of these things. Our minor axis should go through our center and be up and down. So it should be 2. So we want to go up and down 2. So it's right. No, up and down 1. What am I doing? Whoop. There we go. So just a little skinny guy. So it should go through the top of the minor axis, through the vertex, bottom of the minor axis, and through the other vertex. That looks like a terrible ellipse, but I mostly care about this stuff going on here. The whatchamacallit, the algebra, and using these formulas and calculating that stuff appropriately.